Now the chapter which we are going to start is logarithms. The chapter logarithms is very useful, not only in mathematics but also in chemistry and physics, and wherever calculation, numerical calculations are there, logarithms are useful. Now, 2 cube is 8, we know, and 3 power 4 is 81, and 7 square is 49. So when the number 2 is raised to the power 3, the answer is 8. Or to get 8, 2 must be raised to the power 3. In the same way, to get 81, 3 must be raised to the power 4. And to get 49, 7 should be raised to the power 2. Therefore, logarithm of 8 to the base 2 is 3. We have to read it as logarithm of 8 to the base 2 is 3. That means if we raise 2 to the power 3, we get 8. And similarly here, logarithm of 81 to the base 3 is 4, and logarithm of 49 to the base 7 is 2. So the logarithm of a number is the value to which the base should be raised to get the given number. So now 2 cube is 8. To get 8, 2 must be raised to the power 3. That means logarithm of 8 to the base 2 is 3. And logarithm of 81 to the base 3, to get 81, 3 should be raised to the power 4. And to get 49, 7 should be raised to the power 2. This is basically the raw definition of logarithm. Now actual definition. If capital N, comma, A not equal to 1, or any two positive or real numbers if n comma a not equal to 1 or any two positive real numbers, and for some real value x, if n is equal to a power x, then the logarithm of n to the base a is x. We write this as log n to the base a is equal to x. So therefore, if n and a not equal to 1 or any two positive real numbers, And for some real value of x, if n is equal to a power x, then the logarithm of n to the base a is x. We write log n to the base a equal to x because a power x is equal to n. Now let us observe logarithm of 64 to the base 2. That means to get 64, to which power 2 must be raised? 2 must be raised to the power 6. So logarithm of 64 to the base 2 is 6, and logarithm of 64 to the base 8 is 2, because 8 square is 64, and logarithm of 64 to the base 4 is equal to 3. We have calculated the logarithms of the same number for different bases. So log 64 to the base 2 is 6, and log 64 to the base 8 is 2, and log 64 base 4 is 3. That means logarithm of the same number to different bases are different. So the conclusion is logarithm of a number to different bases logarithm of a number see, let us logarithms of the same number to different bases. Logarithms of the same number to the different bases are different. This is one of the important points. So therefore, first we have calculated log 64 to the base 2 is 6, because 2 power 6 is 64. And log 64 to the base 8 is 2, because 8 square is 64. Log 64 to the base 4 is 3, because 4 cube is 64. That means we have taken the logarithm of the same number 64 in all the three cases, but the bases are different. So therefore, logarithm of the same number to different bases are different. Now, logarithm of 1 to the base 2. To get 1, 2 must be raised to the power 0. In the same way, logarithm of 1 to the base 5, this is also 0, because 5 over 0 is 1. And logarithm of 1 to the base x is also 0. So in the beginning, log 1 to the base 2 equal to 0 we have observed, because when 2 is raised to the power 0, we will get 1. In the same way, when 5 is raised to the power 0, we will get 1. And x when raised to the power 0, we will get 1. Therefore, logarithm of unity to any base is 0. Logarithm of unity to any base is 0. So in the previous example, we have seen that logarithm of the same number to different bases is different. Now the logarithm of unity to any base is 0. Logarithm of 8 to the base 8 is 1, because 8 power 1 is 8, and logarithm of 5 to the base 5, this is also 1, and logarithm of x to the base x is also 1. So 8 power 1 is 8, therefore log 8 to the base 8 is 1. 5 power 1 is 5, therefore log 5 to the base 5 is 3 power 1 is x, therefore to the base x is 1. So with all this, we can conclude that logarithm of any number to the base itself is always unity. Logarithm of any number to the base itself is always 0. So logarithm of unity to any base logarithm of any number to the base itself is unity. Logarithm of any number to the base itself is unity. Logarithms were first introduced by a famous mathematician, John Napier. And hence the logarithms which are calculated to the base e are named after him as Naperian logarithms as well as natural logarithms, because he calculated the logarithms to the base e. So hence the logarithms which were calculated to the base e are called as Naperian logarithms or natural logarithms. So therefore logarithms calculated to the base E are called as Neperian logarithms. Or natural logarithms. So, for any given logarithm, unless the base is specifically given, we will accept the logarithms to the base e, and if nothing is written, then we have to take the base as e. So therefore, suppose if we take log x, it means the base of this logarithm is e. So when we do not write any base, then also we mean to say that log x is defined to the base e. Now, logarithms calculated to the base 10 are called as Briggs logarithms. So if we do not mention any base, we will take it as a Neperian logarithm, and the base is understood to be e. And if the base of a logarithm is 10, then they are Briggs logarithms. No. Prove that logarithm of AB to the base x is equal to log A base x plus log B base x. So we are asked to prove that logarithm of AB to the base x is log A base x plus log B base x. Now, let log AB to the base x is equal to P, and hence this implies x power P is equal to AB. And log A base x is Q, and this implies x power Q is equal to A. And log B base x is equal to R, and this implies x power R is equal to B. So therefore, logarithm of AB to the base x is P, therefore x power P equal to AB. In log A base x equal to Q, therefore x power Q equal to A. In log B base x is equal to R, therefore that implies x power R is equal to B. Now, if we take the first result, x power p is equal to ab, and here the value of a is x power q and the value of b is x power r. Therefore, this is equal to x power q plus r. Because the two quantities are getting multiplied, the base is same, therefore we have to add the exponents. Therefore, P is equal to Q plus R. That is logarithm of AB to the base x is equal to log A base x plus log B base x. Therefore, log AB to the base x is equal to P. This means x power P equal to AB. Log A base x is equal to Q. Therefore, x power Q equal to A. Log B base x equal to R. This implies x power R equal to B. Now, x power P equal to AB. A is x power Q into this is x power R. Therefore, this is x power Q plus R. Therefore, x power P is equal to x power QR, that is P equal to Q plus R. P means log AB to the base x equal to log A base x plus log B base x. So, hence logarithm of AB to the base x is equal to log A base x plus log B base x. Now, therefore, log AB is equal to log A plus log B. We are not writing any base, therefore, we can accept them to be Neperian logarithms. And on extension, this log ABC is log A plus log B plus log C. That logarithm of the product of any two numbers is equal to the sum of the logarithms of the two numbers. Now prove that logarithm of A by B to the base x is equal to log A base x minus log B base x. Now, first let us take log A by B to the base x to be P. So, this implies x power P is equal to A by B. The next one, log A base x, let us take this as equal to Q, and this implies x power Q is equal to A. And the next one, log B base x is equal to Q. This implies log B base x is equal to R, because Q already we have taken. Log B base x equal to R. This implies x power R is equal to P. Therefore, logarithm of A by B to the base x is taken as P. Hence, x power P is equal to A by B. Log A base x is equal to Q. Therefore, x power Q is equal to A. Log B base x is equal to R. Hence, x power R is equal to B. Now, let us take the first result. This is x power P is equal to A by B. And the value of A is x power q by x power r. Therefore, x power p is equal to x power q minus r, and hence p is equal to q minus r, and p is nothing but log a by b to the base x is equal to q is log a to the base x minus log b to the base x. Therefore, logarithm of a by b to the base x is taken as p, and hence x power p equal to a by b. Log a to the base x equal to q, and hence x power q equal to a. Log b base x is r, x power r equal to b. Now x power p is equal to a by b. Value of a is x power q by x power r. Therefore, x power p is equal to x power q minus r, and hence p is equal to q minus r. P means log a by b to the base x equal to log a base x minus log b base x. So from this, we know that log AB is log A plus log B, and from the second result, log A by B is equal to log A minus log B, and logarithm of AB by CD. In the numerator, they both are multiplying, therefore it is log A plus log B minus log C minus log D. So according to this principle, it is log of AB minus log of CD. Log of AB is nothing but log A plus log B. Minus of log of CD means minus log C minus log D. So in ordinary calculations, we can use all these things as formulae. Log AB is log A plus log B. Log A by B is log A minus log B, and log AB by CD is equal to log A plus log B minus log C minus log D. Logarithm of a power m to the base x is equal to m log a to the base x. This is what we are asked to prove. So prove that logarithm of a power m to the base x is equal to m log a base x. Now, log a power m to the base x, let us take this as p, and hence this implies x power p is equal to a power m. And logarithm of a to the base x, let us take this as q, and this implies x power q is equal to a. Now the first result is x power p is equal to a power m, and the value of a is x power q. Therefore, this is x power q to the power m. Therefore, x power p is equal to mq, x power mq. X power p is x power mq. That is, p is equal to mq. So this is the result which we got. Now the value of p is nothing but logarithm of a power m to the base x is equal to m into q is log a to the base x. Therefore, finally we arrived at the result log a power m to the base x equal to m log a to the base x. So we have to prove that logarithm of a power m to the base x to be equal to m into log a base x. Now logarithm of a power m to the base x we have taken as p. Therefore, x power p is a power m. And log a to the base x is taken as q. Therefore, x power q is equal to a. And hence, x power p equal to a power m, that is equal to x power q to the power m, because a equal to x power q. Now this is x power p equal to x power mq. From this, p is equal to mq. P means logarithm of a power m to the base x is equal to m into log a base x. Prove that logarithm of a power m to the base x power n is equal to m by n into log a base x. Logarithm of a power m to the base x power n, this let us take it as p. So this implies x power n to the power p is equal to a power m. Now log a base x, this we will take it as q. This implies x power q is equal to a. Now the first result, x power n to the power p is a power m. That is, x power np is equal to a means x power q to the power m. Therefore, x power np is equal to x power mq. And from this, np is equal to mq. And p means, this is n into p means log of a power m to the base x power n is equal to m into log a base x. If we send n to the other side, we will get log of a power m to the base x power n equal to m by n into log a base x. So logarithm of a power m to the base x power n, we have to prove that it is equal to m by n into log a base x. The first one, logarithm of a power m to the base x power n, is taken as p. Therefore, x power n to the power p is a power m. And log a base x is taken as q. Thereby, x power q is equal to a. Now, x power n to the power p is equal to a power m. Here we have got. And the value of a is x power q to the power m. Therefore, x power np is equal to x power mq. Now np is equal to mq. That is, n into p means logarithm of a power m to the base x power m equal to m into log a base x. When we send n to the other side, logarithm of a power m to the base x power n is m by n into log a to the base x. Prove that log a to the base x is equal to log a base y into log y base x. Log a base x, this we will take it as p, and this implies x power p is equal to a. Log a base y is equal to q. This implies a is equal to y power q. And log y base x, let us take this as r. This implies x power r is equal to y. When we have taken the first result as p, x power p equal to a, and log a base y is q, therefore a is equal to y power q, and log y to the base x is r, x power r is equal to y. Now, the first one is x power p is equal to a, and a is y power q, y is x power r to the power q. Therefore, x power p is equal to x power qr. So this implies p is equal to qr. But the value of p is log a base x, and q is log a base y, and r is log y base x. So therefore log a base p is equal to a base x equal to p, that means x power p equal to a. Log a base y equal to q, that is a equal to y power q. Log y to the base x is r, that is x power r equal to y. Therefore x power p equal to a. This is the result. The value of a is y power q, and the value of y is x power r, hence x power r whole power q. Therefore x power p is x power qr, and hence p is equal to qr. Now write the values of p, qr. Log x is equal to log a base y into log y base x.